Okay, what is the relationship between arrays and pointer? Okay, if we declare an array, so for example, the array integer int and the array name is vals, and this is the initialization of the array. So there are 3 elements here, 4, 7 and 11. If we visualize this array, so we have the array names. So this is the array vals 0, the element 0, 4, element 1, index 1 is 7, index 2 is 11, and this is the address. So 001 is the first element's address, 002 is the second element address, and 003 is the third element's address. Actually, when we declare or define an array, so the array name is actually refer to the starting address of the array. So if we just see out the array names, val for example, it will display the address of the first element. And if we see out element names together with the index number with this symbol, square bracket, and then it's index number in the between of square brackets, and it will display the content of the first element of the array. So basically, vals is the array, the address of the first element in the array. So this is a type of pointer also. It point to the it keep the address of the first element of the array. Therefore, array name can be used as a pointer constant. So we can use this vals. So because we have a array vals, and we can use this vals, and when we add asterisk with the array name, it will actually display the first element of this array. And because when we declare this array, the name of the array will point to the first element of this array. So it will refer to this element. The first element is 4, the value is 4. So that's why when we derefer to this point, it will display 4. And pointer also can be used as array name. For example, we have a declaration here. So this val ptr is a pointer because you can see the symbol asterisk here, and it points to this array vals. So no need to use ampersand here because this is actually already a pointer. So when we refer to these elements, so val ptr and element number 1 here, it will refer to this element because it will refer to the element index 1. So that's why it display number 7. So it will, if we put 0 here, it will display 4. If we put 2 here, it will display 11. So this is what happened if we visualize this declaration. So when we have val ptr, and then we point, because we have star here, asterisk, point to the first element of array vals. So here, and it will actually keep the address of the first element of the address, the first element of the array vals. Okay, now we look at another example. So let's say we have a declaration of constant integer size equal to 5 and double coins, and we have this array double coins and the size is 5, and this is the value of this array, the initialization of each element in this array. And we have one pointer. The type of this pointer is double, and the name of the pointer is double ptr, and you see here asterisk symbol, this is a pointer. And we have the assignment here, double pointer is point to the array coins, the first element of array coins. And if we see out the first element in coins array is, we use this symbol dereference asterisk double ptr, it will print 1.2 because this one is actually referred to the first element of this array, coin array. So we'll get this as the output. Okay, if we use pointers in expressions, So let's say we have the same example as previous. We have pointer vals, and the initialization of vals is for element 0, element 1, and element 2. And we have a pointer, val pointer, or vals PTR, and vals PTR point to the first element in vals array. So you see the visualization here. So vals PTR is point to the first element of vals array. It keep the address of the vals array. And then what is actually vals PTR plus 1? So it means that the address in vals PTS plus 1 times size of integer. So actually it goes to the next address of vals PTL. So if the initial address is 0001, so it will go to the next address of 0001. So it means it go to 0002. So if we do the operation val PTR plus 1, so the address plus one address is go to the next address, and this one is actually refer to this element number 7. And same if we plus 2, it go to the next two address, so address number 1 and address number 2, and it will go to the third element. So if we display or we see out, you will get 11. So to use this expression, we need to use in bracket here, and the operation here, and then we need to use asterisk. So in terms of priority, it will do this addition first, and then dereference to the address, and same with here. So the operation must be between inside the bracket. So array elements can be accessed in many ways. It's either we use the element number. So if you have the array vals, and then we can refer using element number. This is the normal one. And we can use also pointer. We can use pointer. So if we point a pointer to an array, the first element of the array, so the pointer name can be used as a array name also, and we can also use the element index, the index of the element to refer to the certain element. And we can use array name and the subscript arithmetic. This one, as the previous example, we use the operation with the array name or with the pointer name. So both can get the same results. So if we use the pointer name, if we use the array name and plus 2, this one actually refer to the third element of the array. The third element of the array. So the next two elements of the array. So same with this. So but you need to use bracket, and the operation is inside the bracket, and then you need to use this symbol, asterisk symbol. So you can see example here. So the same array coins as previous example. So the size is 5, and the initialization here, and we have one pointer, double pointer, and this I is for the counter. So we assign the pointer double PTR to array coins. So we assign this to array coin. It means this double PTR will point to the first element of array coins. And then the value of coins, we can use, if you want to refer to each element in this array, we can use the double pointer instead of coins. So we use the same, because double pointer is point to the coin array, so we use double PTR and then the index. So this one will print all element in coins array. It's just like we use, this is a coin array, so it doesn't, because it will give you the same output even you use double PTR or use coins here. And also the other way to print the content of the array, so you can use the coin array names, the array names coins, and you can use the operation I. So plus the first value of I is 0, so coin plus 0 is the coins, the array, the element 0, index 0, and then 1, index 1, 2, and 3. So this one also will produce the same output. So you can either use this approach to refer to the elements in the array using the pointer name, but you need to assign first. So make sure to refer the pointer to the array first, and then we can use either double PTR or you can use coins here, and both will produce the same output. And this one also refer to each element in coins array. This one also refer to each element in coins array. Next, we're going to look at operation on pointer variables. Okay, let's say we have this initialization or declaration of array vals, and the initialization of each element in array val is the first element is 4, and then we have second element 7, and then the third element is 11. So we have a pointer val ptr, and the val ptr is point to the array vals, the first element of array vals. And then if you have some operation here, so let's say we do the operation vals ptr plus plus, it means that it refers to the next address of the element in the array vals. So the next address is 7, so it points to 7. And then we have a var ptr minus minus. Now it back point to the first element, because the current let's say this address is 001. The first element is 001, and then we add 1, it go to 002, and then we minus back, and then we go back to 4, point back to 4. So if we have another operation, vals ptr plus 2, so it will refer to the third element in this array. Okay, so we do some reassignment here. So vals ptr is equal to vals, so it actually is refer to the first element of the array, and then vals ptr plus 2. Yeah, vals ptr equal to vals ptr plus 2. So actually it points to 11. And then we have this one, the difference, vals ptr minus var. This is the difference between vals ptr and vals. So if you want to compare pointers, we can use relational operator, less than, greater than, equal, and etc. So it can use to compare the address of the pointer. So to compare the address, we can use, for example, we have two pointers, ptr1 and ptr2. So we can use this address to make sure to compare the address. It means that this pointer is referred to the same pointer that pointer to refer to. So if we want to compare the content, we need to use asterisk. You need to use asterisk ptr1 equal to asterisk ptr2. So this is to compare the content, and this one to compare the address.